So I'm not sure why, but the last problem did get cut off on the movie, and so this is a continuation of 45. And the answer to the delta G for 45A was negative 801 kilojoules per mole. And that means that that reaction is spontaneous, because when delta G is negative, it would be a spontaneous reaction. Okay. Part B. 6CO2, we have this reaction here. And the delta H, to find the delta H, we're going to do the product delta H's minus the reactant delta H's. And so I just wrote them down as 1 C6H12O6, delta H of that, plus 6 of the delta H of O2, minus, and then in parentheses, 6 of the delta H of the CO2, plus 6 of the delta H of the H2O liquid. Okay, so to do the delta H one, I've already looked in the appendix for these values. So the C6H12O6 is negative 1,275 kilojoules per mole. O2, well, that's the element in its element state, so that's just 6 times 0, which is just 0. So that's the first part. And then subtract 6, in parentheses here, 6 times the delta H of CO2 gas is negative 393.5. And 6 times the delta H of the H2O liquid, so that's not the same as the gas state, that's minus 286. And then if we do that on the calculator, we get negative 1275, and then minus, in parentheses, 6 times negative 393.5, plus 6 times negative 286, and we get 2,810. So this is 2,802, and that would be kilojoules per mole. So that's the delta H of that reaction. Okay, next one. Delta G, or we'll do delta S next. So the delta S, I'm not going to rewrite the whole thing because I have the sort of structure. So it's 1 times the S of C6H12, and so the S of C6H12 is 212, plus 6 times the S of O2, and the S of O2 is 205, and these are in joules per mole Kelvin, minus 6 times the S of CO2 gas, that's 214, plus 6 times the S of H2O liquid, which is 70. Okay, so instead of writing all of these as S's, I just use the delta H as my guideline. And so I have 212 plus 6 times 205 minus, in parentheses, 6 times 214 plus 6 times 70. And we get a delta S of negative 262. And that would be in, 2 joules per mole Kelvin. And then we're going to do our delta G. And our delta G is going to be 1 times the delta G of C6H12O2, negative 911 kilojoules per mole, plus 6 times the delta G of O2, which is 0. Right, so that part goes to 0, minus 6 times the delta G of CO2, so negative 394, plus 6 times the delta G of H2O liquid, which is negative 237. And again, we plug those into the calculator, and we get negative 911, minus, in parentheses, 6 times negative 394 plus 6 times negative 237, and we get that this equals the delta G 2875 kilojoules per mole. Okay, next one. Your answer key says 2880 because of the sig figs here. So we can only keep 3 sig figs. I'm just going to leave it as that. Okay, so we'll try to go through these. If the video cuts off, just look at the PDF, but essentially I think you get what we're doing. So on this one here, we're going to say delta H is equal to, and I won't write the formula, you know, I have the general formula up here, and I'm just going to go right into it now. So products, 4 times the delta H standard state of H3PO4 minus, in parentheses, 1 times the delta H in standard state of the P4H10 solid plus 6 times the delta H standard state of the H2O liquid. Okay, so I have these looked up already. So we have 4 times the delta H in standard state of the H3PO4, that's negative 1279, minus, in parentheses, 1 times the delta H of P4H10, negative 2984 kilojoules per mole, plus 6 times the delta H of the water, which is negative 286. And then we take the calculator. Again, we plug this in. So we're going to say 4 times negative 1279 minus, in parentheses, minus 2984 plus 6 times negative 286. And we get negative 416 for our delta H. So this is an exothermic reaction. That's kilojoules per mole. Then we'll do the delta S, standard state, and that's going to equal the S of the products. So 4 times the S of the H3PO4, which is 110, minus, in parentheses, 1 times the S of the P4H10, which is 229, plus 6 times the S of the H2O liquid, which is 70. And so when we do that on the calculator, we get 4 times 110 minus 1 times 229. Oh, in parentheses, see, in parentheses, 1 times 229, which of course I don't need to do that 1 times, but 6 times 70, in parentheses, and I get a delta S of negative 209 joules per mole Kelvin. Means it's getting more orderly, right? If the S is negative, it's getting less disorderly, more orderly. That makes sense. I'm going from a solid and a liquid to a solid. That's more orderly than 2, and one of them being in the liquid state, so that would make sense. And then lastly, we'll do the delta G. And so the delta G, same process, standard state. We're going to say 4 times the delta G of the H3PO4, which is which is negative 1119. Let me erase that. So the delta G is negative 1119. I was reading the wrong column. Minus, in parentheses, 1 times the delta G of the P4H10, which is negative 2698, if you look these up in the back of your book, plus 6 times the delta G of the H2O liquid, which is negative 237, so 6 times negative 237. And plugging that into the calculator, we get 4 times negative 1119 minus, parentheses, 1 time, so I'm not going to do that, negative 2698, plus 6 times negative 237. And we get delta G is equal to negative 356 kilojoules per mole. Okay, next one, part D. And if this cuts me off, just look at this on the PDF that I post. So delta H in standard state is going to equal 1 times the delta H of the ammonium chloride solid minus, in parentheses, 1 times the delta H of the HCl gas plus 1 times the delta H of the NH3 gas. And that's going to be delta H of ammonium chloride solid is negative 314 kilojoules per mole. Delta H of the hydrochloric acid in the gas form is negative 92. And delta H of the ammonia gas form is negative 46. And since all of the coefficients are 1s, I don't have any multipliers, so this is an easy one to do. So we're going to say negative 314 minus, in parentheses, negative 92 plus negative 46. And that's equal to negative 176 kilojoules per mole. That's the delta H. We'll do the delta S next. So the delta S is going to be 1 times the S of the ammonium chloride solid, which is 96, minus, in parentheses, 1 times the S of the HCl gas, and that's going to be 187, plus 1 times the S of the ammonia, which is 193. And when we do that on the calculator, 96 minus, parentheses, 187 plus 193, and we get minus 284. And that's our delta S, joules per mole Kelvin. And then lastly for 45, the delta G, that's going to equal the delta G of the NH4Cl, the ammonium chloride, so that's negative 203, minus, in parentheses, 1 times the delta G of the hydrogen chloride, so negative 95, plus 1 times the delta G of the ammonia, so negative 17. And, oh, I miss being in class with you, but let's do it this way for today. Negative 95 plus negative 17, and we should get negative 91. And that's our delta G in kilojoules per mole. And again, because it's negative, this reaction is a spontaneous reaction. Okay, so that's number 45. I'll put this on a PDF as well so you can see it. And I'll start a new movie for the next section of problems, which I believe is 57 through 65 odd.